Hello everyone, welcome to this video. In this video, we shall be discussing about a question which appeared in GATE exam 2009 and it is of 2 marks. The question here is, if we are given some series of this form summation an z plus 1 whole raised to power n, right? This is defined to be the Lorentz series for the expansion of this complex function f of z, which is sine of z upon z plus 1. This is given to us. Then they are asking what is the coefficient a raised to power a minus 2 for this particular function when we expand it in this Lorentz series of this kind, correct? So this is the question. So in order to recall what we have studied about Lorentz series, let's have a look here. The Lorentz series expansion of any complex function f of z about some point z is equal to a, suppose, right? It is given by the expansion this, where what is this expansion? We have a0 plus a1 z minus a plus a2 z minus a whole square plus a3 z minus a whole cube and so on. These all consist the analytic part, right? And what are these? a0, a1, a2, a3 and so on. They are the coefficients of each of these terms, 1 z minus a square and so on, right? And they are calculated using this expansion. Plus we also have the principal part here, which is what it is. We define and write in notation the coefficient as a minus 1, and it is the coefficient of the term 1 divided by z minus a, correct? Similarly, we have plus a minus 2. It is the coefficient of the term 1 divided by z minus a whole square and so on. So these coefficients are obtained using this formula. There is one way. Another way is what we can do. We can simply expand this function if it is possible about the point. Here in our case, what is the point? The point is simply z is equal to minus 1. We can clearly see from here, right? Because this is how we expand our function. So therefore, if we expand this function about the point z is equal to minus 1 and look at what is the coefficient of what is this coefficient a minus 2, that means we look at what is the coefficient of 1 upon z minus a whole raised to power 2, then we are done with this question. So let's have a look and proceed with the solution. So we have to find this coefficient. So first of all, we need to expand our function f of z about the point z is equal to minus 1. So our f of z, it is given to us in the question as this particular function, correct? So when we expand it, we have sine z upon z plus 1. Now the expansion is quite simple. What you can do, you can just add plus 1 and minus 1 here and then separate the two terms, one with this one and another with this one. So you see first one becomes 1 and the second one becomes minus 1 upon z plus 1, like this. Now you know the expansion for sine function, sine c minus d. The formula you already know, that is sine a cos b minus cos a sine b. So using the formula, your c is what? It is 1, and what is your d? D is z 1 upon z plus 1, correct? And actually in the formula here it should be a and b. Then it is quite okay to write it like this. Fine. So therefore, when you expand it, we have these terms. Now we can further expand the cos function and sine functions. How? We also have the formulas here for sine x. It is x minus x cube upon 3 factorial plus x raised to power 5 upon 5 factorial minus so on. And for cos, we also have the same formula but with the even powers now. So x to the power 0 in the first one, x to the power 2 upon 2 factorial, x to the power 4 upon 4 factorial and so on, with the alternative sign in both the cases. So here sine 1 is as such, the expansion of cos x is this one, right? And then cos x is as such, the expansion of sine x is this one. So now in this expression, can you have a look at the coefficient of 1 upon z plus 1 whole square? We are interested in the coefficient of this term, which is what? the coefficient for this term is actually a minus 2, and this is what is required in the question. So from here you can clearly see this is our term, right? So what is the coefficient? It is sine of 1. This is a constant term, and with a negative sign because we have a negative sign here, and this term together with this. So what is this? 1 upon 2 factorial, which is actually 1 by 2. So this forms your answer, quite. So from here we can clearly see that option D is your correct answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.